Is this okay? All right. Yeah, let me apologize in advance. I was sick like 2 months ago, but for some reason I'm still coughing like crazy. Can't get rid of this cough. I'm going to be talking about JOT tokens, or JWT, not JOT tokens, but JWT. How many people know what JWT is? All right. They suck is the one thing I don't want you to take away from this talk, but there is a very specific use case that I'm going to be talking about that will relate actually to what Boris spoke about previously. So if you're watching this on the video, go check out Boris's talk as well. But it's for service-to-service communication, and that's what we're going to dig into here, and some of the challenges that can arise when you use JOTs for that. My name is Christian Posta. I'm a global field CTO at a company called Solo.io. We invest heavily in open source projects like Istio and Cilium and Envoy Proxy and Spiffy, Inspire, some of these other. The creators and founders of the Istio project work at Solo, so I will mention that here. And we work with large organizations that are deploying Istio at scale and kind of lead the open source project and the innovations happening in there, some of which I'll talk about. But I'll first start with, we've seen recently some of the security exploits in the wild, but I want to go back about 10 years ago or so, because I think it's still relevant. The way we think about networking and the way we think about architecture and security architecture is in some ways not that different than how we did it 10 years ago, unfortunately. I don't know how many of you all remember the Sony hacks back in 2014. Hackers got into the Sony network and they basically exfiltrated a bunch of very sensitive emails, wage information, and actually got access to unreleased movies and then just published them. Now, the way they did it wasn't all that sophisticated. Well, there's a great report. The FBI actually report that came out like 3 or 4 years after the attack, and I was reading it. It was actually really detailed, and the attack was very sophisticated, but it started off not all that sophisticated. It started off really with getting into the Sony network, and that's actually not that hard. They would send out phishing emails or spear phishing emails and getting people to click on links, which as someone who's very involved in security, I'm like, who's going to click on those links? How many people in this room go through training that say, hey, don't click on suspicious looking emails? And when you get emails, you're probably a little bit vigilant. Coincidentally, probably, this is true, probably about 3 hours before I started reading this report, I got some email from someone. Then I get emails every once in a while asking about how to get into open source, or can you help me with my career or whatever. This person reached out and sent me, hey, I'm looking to make a move in my career. Can you help me? These are the things that I've done in the past. Sent me slides, GitHub links, whatever. Guess what I did? I clicked on those links. The things that I know I'm not supposed to do, I somehow got, even I got tricked into doing that. So getting into the network, clicking on links, downloading PDFs by accident, even if you're vigilant, allow attackers to install ransomware and malware and all this stuff pretty easily. And then from there, they were able to disguise their movement and reaching out to the home-based servers and VPNs and proxies and all this stuff. But the most important bit was once they got in, they were able to move. They were able to get to other parts of the network. And they relied on weaknesses in the network. Not obvious ones, not big, huge holes in the firewall, but people just using default passwords, or people being a little bit sloppy with how they managed their application traffic. And they were able to get into other parts of the network and then start, doing bad things. So the idea, like Boris pointed out, the idea that the perimeter is somehow going to keep people out is not valid, is not a true assumption anymore. What and you probably see a lot of tools have sprung up around intrusion detection and intrusion remediation, assuming that you will get into the perimeter. Now, how do you detect it? How do you remedy it? Now, as we get into deploying in containers and on public cloud and Kubernetes and so on, kind of curious how many people are deploying or thinking about deploying applications into containers and Kubernetes? By show of hands if you can. Okay, so almost half the room. I was working with a large, I won't obviously say the name, but I was working with a large financial institution that the way that, like, their platform team was very security conscious. Their InfoSec team was like, that's just the Kubernetes stuff. As long as traffic goes through our firewalls and gets to the Kubernetes stuff, we don't really care. And that is probably not the right attitude about security when it comes to, deploying more and more services, making changes to these services, more and more APIs that become critical to the business, and Kubernetes, microservices, these sort of practices enable that kind of strategy. So we're going to have more of these moving pieces. And you don't have to trust me for that. There's a bunch of examples of how security should be taken seriously inside of any environment, any platform, but especially Kubernetes. You can read that. So what we want is a secure network. We want to be able to authenticate and authorize every request going over the network. You can read some of the tenets that I wrote down here, and Boris covered this earlier in his talk. This is what Zero Trust is really about. How do we get more fine-grained security, more fine-grained authorization? And that starts with being able to prove an identity about a particular service and how they communicate with each other. And that's where JOT tokens or JOTs come into the picture. Because if we can leverage a stable identity, so if service A says I'm service A and we can prove it, then we can write very powerful policies, and you can use Converno and all these other technologies to implement those policies. Now this is not new, right? In fact, we've done a pretty good job of solving some of these challenges in existing environments. One of the patterns that we used when we started to build out microservice environments was don't let every single application try to implement security on its own. Because it's hard. It might get it wrong. It's going to be duplicated and littered all over the place, be difficult to audit, difficult to make changes. So why don't we centralize it somewhere or have it in one place where we know we're going to get it right, and we run it through the API gateway? How many people run a pattern similar to this for security reasons? Just a couple? I would assume it's a little bit more. Or maybe y'all are just hungry. So this is a fairly common pattern. But once traffic gets into an estate or into a system, we need to solve the challenge of how those services talk to each other. Because it's not always just traffic coming in that we're worried about. Now, we're worried about services communicating with each other in a particular deployment. And so this is the core of the problem, is how do we represent service identity? When service A calls service B, how does B know that that is service A? Now we try to solve this. And I've seen a number of organizations, they just reuse the API gateway. And this is not by itself a problem. This is fine. But the challenge is it's partly is overkill. Probably don't need to do this. The second thing is in practical implementations, what we do is we force the traffic back out through the same gateways to which the traffic came in. So we're sharing these gateways for both traffic coming in as well as traffic inside the cluster. And we get all these hairpinning things and adds more latency, more traffic, more, you start to see noisy neighbor problems and things like that. So this pattern by itself is not bad, it's just how things have been implemented for this particular problem, solving service-to-service communication, is probably overkill. But identifying the services themselves, I mean, I was a developer, I've seen all kinds of things, I've done some of these things myself, and Passing API key saying, hey, I'm service A to the to service B, and service B sees this in a header and says, yep, you say you're service A, that sounds good to me. I'll log it and keep going. Or things like custom tokens and signing and all kinds of stuff. JOTs have sprung up because JOTs are useful. JOTs are being used in various ID, OAuth and access token flows and so on. But for service-to-service communication, what we do is we need to get that JOT somehow and then pass it along in our service communication, which we'll talk about. Another alternative is to use certificates, specifically client-side certificates, to be able to represent the client and do identity verification that way. And the last is, people are constantly inventing new ways to try to do mutual authentication. Cilium, an open source CNI project, tries to layer this on top of the CNI in a completely bespoke way. So this is what we're going to look at. We're going to look at using JOT, JSON Web Token, to identify a service when it's calling another service. We're going to look at some of those patterns, some of the things that you should be aware of. If you're not already, maybe you are, but and then look at alternative ways to do that. By the way, I did not start my timer, so I have no idea how much time I have. Let me know. I know people are hungry, so I'm trying to go quickly. Right. So when I say JOT, I'm talking about JSON Web Token. I'm specifically talking about a blob of JSON that has some stuff in it that claims, the person owning that token claims to be true and is signed by another party, or signed by a key that can then be verified that the claims have not been changed or altered in the process of transmitting that token in a request. So that's what I mean in this case by JOT, JWT. So here's a fairly common pattern. Hopefully some of y'all recognize this. On the left side, you see the API gateway. I'm not talking about the API gateway. So we're talking about the stuff that has already gotten past the API gateway. Now we're talking service to service. Right now, so service A wants to talk to service B. What it'll do is it needs to go get a token that says, hey, I'm service A. I have these attributes. And when I call service B, I'm going to pass this token along. So what it does is it reaches out to some third-party identity provider. In the case, I think this is the OAuth flow, client credentials flow. We're going to say, hey, here's my username and password. Give me a token that says I'm service A. And so it does that. You can kind of see the example there, and then passes that along to service B. Now, if service A wants to call service C, we're going to do the same thing. We're going to have to do the same thing. I don't know if everybody does, but you should. When you call another service with your token, you want to say, hey, I'm service A, but this is intended for communication with service B. So you can't call service C with the same token. You have to get a different token. So that means you got to call that identity provider again, pass the security credentials again over the wire, get a token, and then you can call service C. Now on the other side, B or C or any of these target services, they need to look at the JOT, verify that nothing's changed, so they have to verify it with the keys, and then look at the attributes and trust that those attributes have not been changed. If the audience claim doesn't match, it should throw it away. So it's on the responsibility application to do this. Now, it should also check other things. It should check that the issuer of the token, that they trust it. It should check that it has not been expired. It should check things like when was the token issued, and so on. This puts a lot of demand on developers to get this right. Because for these requests, if we need to get new tokens, we need to, the developers need to check for all of these claims that they get, that they're correct. We should, I think I put this on here, right? We should use TLS. We should at least encrypt the traffic there, because this is a sensitive token that we're putting over the wire. If somebody takes this token, they can potentially impersonate service A. So these are all, there's a lot of moving pieces. So we got to use real certificates. We can't just use self-signed certificates and skip validation, verification, all this stuff, which I've done, unfortunately, and I've seen other people do it too. So I think it could be, you know, something that people do. And all of these things have to kind of, moving pieces kind of have to line up to get it right. Another option is, instead of reaching out to the STS, because that adds more overhead, is to somehow have keys that the service uses to sign the token itself. So it can self-generate the token, sign it, send it off. Same thing though, have to watch out for the expiration dates, have to watch out for audience. The receiving side has to somehow get those keys so that it can verify the JOT hasn't been tampered with. And again, if you're calling other services, you know, this is all really, really important, and also very easy to get wrong and miss some steps, or just use wildcard audiences, or skip checking expirations, or whatever. And it's these little things that you might say in isolation, well, whatever. It's, you know, I pointed out the Sony attack, or any of the, you could look at any of the attacks. They don't rely on one big gaping hole. It's a series of these little overlooks. We're overlooking this one thing. We use the default password here. Who cares? Whatever. It's these things that then get exploited. And the more services you have, the more APIs you have, the more changes you have, the more developers you have, the more difficult it is to get this stuff right. All right, so there's an open source project called Spiffy. S-P-I-F-F-E, I think. .io. Spiffy is an open source project that was designed to kind of help solve this service identity problem. And it goes beyond just this particular use case that I'm talking about. It tries to also solve the fact that we think about security policy in terms of IP addresses and where things are deployed, et cetera, et cetera. Again, take a look at Boris's talk. But it does solve this problem really well. How do we specify the identity for a particular service in a very trustworthy way? And then maybe we can implement this in a way that alleviates developers from having to manage all this stuff themselves. So Spiffy is a specification. It's about how we encode identity. And it's not, you know, super, it's not super concrete, like how we should, what we should do with that encoding, what should we do with this identity structure. But it does give some good options as examples. So taking this identity and coding it into an X509 certificate is a good example, is what's probably most commonly used in implementations of Spiffy. And if a workload can get one of these certificates, now we don't need to mess around with username and passwords. Now we don't need to mess around with putting JOTs on the request. We just open the connection and start using the certificates at layer 4 to handle authentication, mutual authentication between services. So the Spiffy spec explains how to structure the identity. It's basically a trust domain or a group, organization potentially, / business unit / service name. And that part's flexible. You can label that however you want. Excuse me. You can be encoded, this can be encoded X509 certificate, which is preferable. And the least preferable is you can still do this in JOT tokens if you absolutely need or can't do certificates for some reason. So the way this works is service A comes up, it says, hey, reaches out to a Spiffy implementation, which I'll talk about in a second, and says, hey, I'm service A, give me the credentials, give me the certificate, the SVID, or the thing that represents me, so in this case it's a certificate. And the Spiffy implementation will say, I don't know if you're service A. I need to go figure that out. And it's not going to trust whether you send me username or password. It's going to go look. Where are you deployed? What labels do you have? Does the operating system think you're this? Does the platform think you're this? Like, it's going to go back and basically do a background check and say, okay, yeah, you are service A. So we don't need to mess around with client username, passwords, and Vault integration, all that stuff. Spiffy will go actually validate and verify this. So then, if it does, then it'll give the workload this their certificate. And the same thing can happen on workload B. So when things come up, it'll verify this is workload B, give you a certificate too. Now when we make the call, we can just use TLS. Use these certificates using TLS, using MTLS. MTLS already does mutual authentication, and it does it really well. Right? It does other things too. We get an encrypted traffic, which is good. I mean, compliance, all this stuff needs that too. It does integrity checking. So you get all these things, I don't want to say for free, because it's still, you have to implement it somehow. But if you can get to TLS or MTLS, this solves the problem with slinging JOTs around and expecting developers to get everything right every single time. And you get a better security posture. Everything's encrypted, which is exactly what this slide is intended to depict here. So now we get traffic coming in. We can check it, alleviate, offload some of the security aspects from the applications to the gateway. But now we can also simplify how applications think about doing mutual authentication in their service-to-service communication. Spire is a implementation of that Spiffy spec. It's the thing that goes and does the attestation, or the background checking. It can issue these certificates, and that's all I'll say. Y'all can go look at that, but I just want to point out this is an implementation. There are challenges to doing this, though. This is not free. So you still have to manage certificates. Now, if you were to do it with JOTs today, like I mentioned, you shouldn't be sending those tokens over plain text, right? So you should have some mechanism for doing certificate management already, at least for half the services. So if you extend that to the rest of the services, my point is it's still not easy. You still have to do it, and you have to handle the key materials safely and so on. Istio is another implementation of Spiffy. So the Istio Service Mesh project implements this workload API and issuance and rotation and revocation and automatic injection of the certificates into the connection so that applications really can just be, don't have to think about this or don't have to implement this themselves. We've been working upstream, and it's about to be, I think in the next release, it'll be production ready, is a sidecarless option for Istio. If you all are familiar with Istio, you're probably familiar with the pattern that's been around for about 7 years, which is deploy a sidecar next to your application. There are some challenges to that. There's some costs associated with that. The sidecarless option tries to minimize some of the friction to adopting Istio and basically make it transparent. So the sidecarless approach is called ambient mode or ambient mesh. And what it looks like is a little security agent gets deployed on each node and is responsible for injecting the certificates into the connection. That's the most terse that I can be about what it does. So now you don't need gateways. You don't need proxies to do this. You deploy an agent, a daemon set onto each of the nodes in your Kubernetes cluster, for example, or your VM or wherever, and you can just get mutual TLS. The agent knows how to associate the right certificates with the right workloads. And in fact, as the traffic is leaving the pod, for example, in Kubernetes, as it's leaving the workload pod, that communication is already encrypted and guarded by mutual TLS. So like I said, it's transparent to the application. It is tied into the Spiffy spec, which then is tied into the rest of your public key encryption and infrastructure. So probably stuff that's already there and uses and leverages this this workload identity, not based on tokens and stuff, but based on spiffy, that then can be used to write network policies. And those policies are, it doesn't, like I said, it doesn't depend on IP addresses or where things are deployed. Applications are probably moving and failing and doing all this stuff anyway, running in serverless environments and anywhere. Spiffy is a better approach to handling workload identity than our previous generation of network policy implementations. The last thing I'll say is networking should be thought of in layers. A concept that we've been working on at Solo is how do you take open source, we think the best of breed open source projects, put them together to provide a very powerful networking and security solution that then can be tied into modern concepts like GitOps-based workflows and CI/CD and Kubernetes, using declarative configuration. And we think, you know, the networking layers kind of look like this. So I'll end with maybe some additional resources, some other things to take a look at. I appreciate y'all coming. And I don't know, do I have a minute for questions or something?
You do have some time for questions.
Okay. I do have a signed copy of my book, not this one, the Istio in Action book, the Manning book. So if anybody asks a good question, I'm willing to part with it.
We got a prize. You scared them.
They don't believe I have it. Let's see.
Yep, there it is. Anyone got a question? Oh, yeah. Oh. You got to ask a good question. Okay. Anyone? Wow.
Back there.
Oh, he's slinging it. Oh. Well, it's the only one.
Other side. No, I'm just kidding. There's no back
Okay,
questions.
I'm pretty sure we have our JOTs implemented okay, but not great. Just like you said, there's a lot of details in there. So like, I was taking notes. I'm like, oh, we need to look into all these details and fix our JOTs. But then you're talking about spiffy. So what I'm wondering is, we're not in Kubernetes. That complicates a lot of things because it seems like all solutions are made for Kubernetes. We're more on, it's like, yeah, we're on Cloud Run in Google Cloud. So it's like, it's abstracted. But in any case, is this like, should we try to fix our JOTs or should we move to spiffy? Is this something that we need to like completely, could we just like, is this something that we need to completely re-architect everything, or is this something we can drop and replace into our existing architecture without you knowing what our existing architecture is?
Right. So the way they'll answer that is, should you fix your JOTs? Yes. And like I probably didn't point it out that well, but I didn't go into too much detail about Istio Ambient. But we're working to make Ambient run on any platform, and do so in a way that is even more. We don't want it to be intrusive to the application or to your architecture, right? We don't want to force you to say, "Hey, run in Kubernetes." We do have Ambient working very nicely right now in VMs. We in Solo, we're slowly open sourcing this stuff, but we want to be able to meet people where they are in their architectures, where they are, whether that's Cloud Run or VMs or physical or serverless or functions as a service, wherever. And the work that we're doing is in that direction. So I would say, yeah, fix your existing, JOT implementations. That might be a pain in the ass, but you should do it. And then, we're trying to make this more available to folks, especially outside of Kubernetes. There's another question back there. I don't know what the.
Sorry, making you run there. And forgive me, maybe I just wasn't connecting the points, but I'm still not 100% sure on how spiffy protects you if like a service gets compromised, because then they're already in service, right? So could they not then request these?
So the question is, how does spiffy help you if a particular service gets compromised? That was you that asked the question, right? So if a service gets compromised, what you want to do is, first of all, detect that, and then limit the blast radius for what happens from there. It's a good question because how many are Java developers? I'm kind of curious. How many people are Java developers? A handful. Me too. The fact is, application code is probably the largest target for various vulnerabilities, right? I'm not picking on Java, but we've seen that, right? And so if you get access to somehow compromise the code, what you don't want is then that to spread. And if you inject private key material, insert passwords and JOTs and all this stuff into the app, the attacker has access to that, right? And so the way that we've built, I can put the diagram back up, but the way that we've architected Istio's ambient mode is in a way that there's no sidecars deployed with the app. The app runs as itself. If it gets compromised, it doesn't have access to the certificates. It doesn't have access to the MTLS mechanism. Now, the agent that does, has to be. You can't just inject random code into it, right? It has to be hardened. It has to be simple, and it has to be locked down, similar to other agents that you already have running on, for example, your Kubernetes cluster, right? You have the kubelet running on, your nodes. You have the various CNI agents that are already. All of those have to be locked down exactly the same. So this is an agent that needs to be treated the same way. But the most important thing is don't let it spread, or at least understand what your blast radius would be. Sorry, you guys keep.
It's all good. These are great questions.
Hey, Christian, do you still see people doing claims-based routing on JOT tokens? And in the event that they want to do claims-based routing, do they still send the JOT token along in the header?
Yeah. There's nothing wrong with JOT. I started off by saying that JOT tokens are still useful, but for the service-to-service based authentication or mutual authentication, I'm saying that there's probably a better way. But when your user logs in to the app and goes through the OIDC flow or whatever they're doing, there's still tokens that you want to pass along that represent the end user. And you still want to be able to look at what does the user have access to and do all this other stuff. Definitely pass those tokens along or scope them down as you pass them. But people definitely still need to do that.
All right, I'm going to cut it off.
Yeah.
My stomach is growling. Thank you so much. Another round of applause, please.